Welcome back, everybody. So yesterday we worked on the, excuse me, I can't do two things at the same time. We worked on the miniPCB datasheet. And yeah, so this is what it looks like. I was watching the video and I caught one or two errors, things I thought were errors, so I came in and I fixed them. But first page, you've got your circuit name, detail table, 3 sentences describing the circuit that's on the board, a picture of the front and back of the panel, a picture of the front and the back of the individual board, a picture of the generated from CAD of the top side and the bottom side. The reason why you'd have this one and not the other is this guy is focused. It's like a highlight of what parts are on the board and where they are located. So you might say it's the component view. And the schematic, which I'm going to try to keep to a single page, but I'm not going to limit myself if it has to go to 2 pages. This is just the template. I can always have another page. After the schematic, then there will be it feels a little cryptic. So maybe I will put something to buffer between the schematic and this. And I guess so the theory of operation, Dave Jones over on the EEV blog did a video, or had in one of his videos, he showed like a document that I think it was Hewlett Packard, but maybe it was a Heathkit. But it was just a very detailed old, talked about the theory of operation and this and that. So, okay, so got the 3 sentences there, but right between the schematic and the design inputs would be a good place to put that type of like circuit description. Circuit description, but it's like the description of what is going on. Which is basically the theory of operation. Anyways, there's something that has to fit between schematic and design inputs, because the schematic shows you the design, and the design inputs are the requirements for what you as the designer can control when this circuit is being used. And it's, I guess, once you know, you don't have to, that is in your head, and the next thing you want to see is the design inputs, though. So I don't need to make the data sheet a textbook on day 1. That might be putting too much effort into. Okay, so here will be my compromise. It is a little bit of a harsh transition without an explanation of how the circuit works. But when I create the data sheet, when I'm in because I record everything. Slow down, Nolan. Because I record everything, you'll hear me talk about the circuit. You'll see me go to Google, show you pictures of it. You'll see me come down to Eagle and capture the circuit. on a schematic, you'll see me, tweak the schematic. You'll see me review the circuit, make sure everything's good. You'll see me do the layout, right? I'll talk about what's going on the layout. By the time we get to, you'll see me order it. By the time we get to the data sheet, I've already given you the information about how the circuit works. Yeah, but by the time we get to the data sheet, I felt like I was an eagle. By the time we get to the data sheet, I'll have already told you how it works. So that's why we'll just go from the schematic to boom, the design inputs, and then so there'll be that, and then design outputs, and this is a table that is a form, so parts list form. So this will be blank, and this will be in every miniPCB datasheet. And for every part that is on the board, there will be a row, so that you can, and the row and the reference designator will be pre-populated. This will be pre-populated, but this and this will be blank. Yeah. Those are the ones that will be blank. I had to check if description was blank, because you might say like the size of the part, or no. No. Okay, just those are blank. But these are filled out for you. So that'll be in the data sheet. And that way, this is what the student can calculate, or hobbyist. Yeah. So that sheet in the data sheet I should really move it to just a separate form. No, it needs to be in the data sheet. It needs to be locked to that miniPCB. Yeah. Sorry, guys. Detailed test information. This is where I'm gonna put in basically a series where when you solder parts on, how do you test this circuit? And if there's a potentiometer, how do you adjust it? So it'll be like a adjustment, calibration, test procedure. After that, I'll give you a design example. The design example is going to be a completed, because the first one was a form, so this one's blank. This one will be completed it'll be completed with requirements and characteristics. And then you'll have a parts list, which is slightly different than the one on the top. This one will have a quantity column, and then I will make this during the testing of the miniPCB. And so this parts list will be filled out with the parts that I put into what I designed and tested, and then the stuff that I got, those were the requirements, and then these were the tests that I put it through, and then this was a report, screenshots, all that, from those tests on these components, with these components to meet those specs or meet those specs. And then the data sheet will be over. That'll be the end of it. Yeah. So this was what we did yesterday. And I was thinking today that I probably want to make a macro. This is a macro-enabled template, by the way. And the way that this works, I don't know if y'all watched the ECO-base video, ECO-based video, but the way that the macro-enabled templates work is you can go to the Developer tab, go to Visual Basic, and here's some code that I put into it. And so when I made this one way back when, and almost a year ago now already. Anyways, so here's some code I put into this, and then you can save it. You can have buttons. You can do whatever. Now, when someone creates a document off of this template, that code will be available in the document. And if that's one document, then cool. If it's another document, then cool. Then 3, then 4. And so you could have like 5 documents that all use the code that's right there. And you can change the code that, let's say you create this one on Monday, then you modify on Tuesday, you modify the code in your template. Well, as soon as you modify the code in the template, if you opened the document that you created the day before, that's the code that would run, because it points back to the template, I guess. So anyways, so it's really easy to maintain versions of firmware across documents that need it if you start with a template, macro-enabled template. Anyways, that's how EcoBase works. So it's a macro-enabled template. You click it, it opens a form, and then you fill it out, and then at the bottom it's got some buttons, right? And so you click save and close, and it runs some code that does some fancy stuff that enables an engineering change order system. A very simple engineering change order system that's free. All you need is Microsoft Word, Microsoft Excel. That's it. No licenses, no Microsoft Access. And arguably, it's just as reliable as all those Microsoft Access engineering change order databases that are just haunting the world, arguably. But anyways, so this is how EcoBase works. Yeah, okay, so that's what we did yesterday. And sorry, I'm rambling, but what I wanted to do today in this video was to go over to Eagle and work on the script that I used to generate this, and see if we could modify it to generate a view of components on the bottom side. So it's been a while since I was writing scripts in Eagle, so you'll just have to bear with me. I haven't been in there earlier today refreshing myself, so this may be a little slow. So over here, so this is an older version of Eagle. I have a bunch of mini PCBs already created. I'm going to do a good number of them here in this older version, and then maybe 1 or 2 of them will sell, or maybe I'll just, save up a little bit of money every month, and then I'm going to buy the latest version of Eagle, which I've previously had. I didn't really use it that much. Okay, almost not at all. But I figured I would just force myself to upgrade and transition over. And so then all the boards that I do here in the older version will kind of create a, what Eagle was before Autodesk acquired them. And then all the videos I do after will be, oh, hey, here's what you can do with it now. Like they've really helped it as a tool. So okay, anyways, enough of that. Export part image. This is the script. Sorry about that. This is the script that just realized y'all couldn't see that on the side down there. Huh. Well, export part script. So there's the scripts. Okay, so I wrote this sometime last November, and let's see what this does is it design rule check load, and then I have a design rule file that I call miniPCB.dru. Set palette. I do that for some reason. I forget. There's some setting. I think it has to do with the view, but there's some setting that is in the design rule that is needed to get the right view. or something like that. Set palette white. Oh, no, I know what it was. It was something else. Anyways, set palette white, display none. So this hides all layers so that you can't see anything. And then this turns on so that you can see layer 21, 29, 39, 48, 125. So it turns on those layers. Then the next line right here, export image. So it's gonna export an image of what you see. And the name of the image is going to be components.png. It's going to be a monochrome. This is, I'm not sure what other colors or options. And then 600 dpi, so dots per inch. And then after that, I say display all, set palette black, and window fit. So this is like the very end, but I could insert, well, I could put a couple more lines right here where this is what shows the top, but maybe I do it again where I find what layers I need to be on the bottom. So let me jump into, say, like this board, right? And cancel. Cancel. Okay. Well, let me show you how the first works. Okay, so save. Save. Okay. So from here, I go script. So you click script, and then you navigate to that script, which I believe it's at the top level. Yep. This is the one I just edited today. You double click it. The screen flashed. It went back to fit. And if we navigate to that folder, 00A10, we have a new PNG, components PNG, and this is what that generated. Yeah, and it messes up the logo because I changed it. Yeah, we changed it to have an offset the copper. So now I wonder why it's got this white section down here, right? Not sure about that. The other thing I want to do is I want to put a frame on this, and I want the frame to be a certain size. Now, this is 100 millimeters wide, so that frame would have to be, well, at least 120 millimeters. I was trying to think in inches, but at least 120 millimeters. Might as well do yourself a favor and stay easy, right, Nolan? Okay, so yeah, draw frame. Give me a 10 millimeter. Start it back here. Take it to up here. Put it like that. Right click, properties, border, none, none. Where does it say none? Okay, I don't think I'm just missing it. I don't know. Apply. Yeah, it's not what I want. Let's do bottom, top, bottom, top, top, bottom, bottom, top, left. What? Right, top, bottom, right, top, left, bottom, left, right, left, bottom, right, left, top, left, bottom, top, left, right. Where's just like bottom, top? Wow. Huh. Okay, but I could do this, right? Yeah. Why didn't it give it to me when I did it the other way? That's weird. Okay, let's do this again. Draw, dimension, start. No, not dimension, frame. Draw frame with a top and a bottom, or do I just leave them all off? I'm going to leave them all off. And we're going to do it like this. This is what I wanted 2 minutes ago. Sorry. Okay. And properties, layer. So Eagle's always had these bitmap layers down here, and I've never thought about what to use them for until just recently. So in the other video when I was like, oh yeah, use a bitmap layer, this is what I was talking about. So I'm going to start with 209. Okay, so 209, and then I want 209 to be a border. So 209 right there. Save. Save. Okay, so now when I run that script, it should have the border on it, and then after that we can go do the next. Yeah. Okay. We'll go back to the folder, double click it. There we go. Now we've got this border around it. And that bitmap layer isn't used in any of the Gerbers, so it's really just there for taking the picture, which I guess is a good reason to call it the bitmap layer. So now how do I get it? Eagle, this version, I'm not familiar with a good way to mirror the layout. So actually, I don't want to look at the mirror function. I want to see if the image function, Eagle script image, I want to see if the image function export. Oh, is it export? What is it? Yeah, it was export. It was export. Okay. So clipboard monochrome resolution. So it doesn't have a like a polarity. I'm able to probably just take the bitmap and do it in Paint, which just another step in the process. I want to minimize the steps. Okay, so that's what's on the image that we export. What do I need to put on the bottom? So if I drag this down, and I'll move it over for you guys. So I've got T place, so probably B place. So that's 22. Let's jump over to what? 22. Okay. Come on, here. So copy and paste. So that's 22. Who wants to bet this one's going to become 30? And so we're changing them now too. So 21 went to 22. T place to B place. T stop to B stop. Yes. So 29 to 30. T keep out to B keep out. Right? They could have. Yeah, anyways, okay. 39 to 40. Document. I think that's the border. I think that's what I put on the border. So I'm going to leave document alone. And T names to B names. Yeah. 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 And I think we should we just leave 209? We're going to leave 209 so that way it just locks everything to be, yeah. So we're going to do that. So 125 to 126. All the way up to 209, but 209 we're going to leave the same. Frame for the top, frame for the bottom. I don't see why we'd put a different frame. Okay. Then we come back to here, and this becomes 30, 40, 49, what? 49, 126. Now, did that sound wrong, guys? These right here, the 40 and the 49, did that sound wrong? 40 and 49. Oh, I left document. That's why. That's why 49 sounded wrong. 40 and cancel. Man, sorry. Y'all were probably like, what is he doing? Like he says it, but you hear Nolan talking, but Nolan's not even there. Yeah, I'm on my second beer. So let's see. So export board image, DRC load, set this, that, export image. So this one, the top. So top components. And then this one will be the bottom. Bottom. Nope, it needs to be components. So that way they show up next to each other in the file system. And by the way, they're at the top. Bottom. Ooh, this is exciting, guys. I think we're almost there. We're on the verge of greatness with this one. Now, Nolan. Stop. Okay. DRC load, set palette wide, display none, display those layers, which give us the image for the top. Components underscore top PNG monochrome. Display none. Display 22, 30, 40, 48, 126, 209. And my microphone's still working good. It'll export that. Display all, set palette black, window fit. Save this. This looks good. This looks good. And then we could just go over to yeah, okay. Let's watch this puppy run. Export part image. Boom. We're back on window fit all. And let's go over to the folder. We got our 2 new images. Top. All right, cool. And bottom, which there is nothing on the bottom. So this is exactly what you want to see, is no parts and no silk screen, because there's no parts and no silk screen on the bottom. I might put the part number. Yes, okay. So we are going to put silk screen over the top of the part number. I believe I have that. No, I took it out of the design standard. But we're going to, I think, or is it, did I not? Now I have to find out. I don't want to move off this folder, so I'm going to just get a new. And I put this in miniPCBs. Oh, by the way, I have a product catalog with an update button, and every time you click the button, it throws an image of the updated chart into this folder. So every time I click that, I get a snapshot of my product catalog. Fun, right? Okay, and then let's see. It was in engineering documents. It got promoted to a lower level folder, and we tweaked it yesterday. So design standard, miniPCB. We want to go down to board layout. Yeah, I think it'd be right here. I think I took it out though. No, here, no, it's there. It's there. Okay, so this is required by the standard, that the part number will be in the bottom copper, and both copper and silk screen. So what that means is it will show up on the board on the silk screen, because it's on the silk screen over here as text. And because it's on the bottom, this would be you'd see it reversed, right? So you'd need to mirror it to so that it displays normal, as if you're looking at it from the thing. So if I wanted to mirror, there's an edit button here somewhere, isn't there? I'm just missing it. Sorry guys, we got to go old school. We're gonna right click and give me paint. Open with paint. Where is my open with? I hope this is the older one. Hopefully it's old enough. There's a mirror right here, right? One of these. This one. That's it. Yep, that's it. That will probably do the trick every time. And that's, I think that may only be possible because of the border, considering the white thing, the white space that it was putting on it. Yeah, yeah. Yeah. Okay, I think that'll work. So don't save. Okay, so so basically what we just did is we added 3 lines. We added 3 lines to a script that we had previously written back in November. This is 25 August. We added 3 lines, and the process, the step of opening this file in Paint and clicking that mirror function, and then now that we did that, we should be able to come over to our data sheet that, say, we're creating at the time, and say insert picture from this device. I'll navigate to that folder. I'll say components, and it will be, wait, this isn't me. This is the one that's not mirrored. Open with, oh wait, there was an open with right there. Open with Paint. Cool. And click the flip that way. Save. Close. Try that again. Change picture from this device. The exact same picture. Yes, that's correct. Yes, this is correct, yeah. And then you'll see the part number over here. Now this board is significantly longer, so in this case, well, size and position, the width can't be more than 3.5. What did I have it at? 3. I'll leave it at 3. Okay. And then this guy, size and position, we'll set this to 3. And then change picture, this device, components, like that. And I don't like the space between the images and their footer thing, so I'm going to take the specified height of the row off, and that pulls that up. And then the size can both be bumped up to at least 3.5. Yeah. Cool. Okay. And then, yeah. This guy's also going to be narrow. Should I do... Should I export multiple bitmaps, 1 bitmap per essentially Gerber file? And then I could put down in the border on the, because I think this is what those bitmap layers are intended for, like 210. So I use 209. So 210 would be like your top copper. 211 might be your bottom copper. 212 would be your silk screen, top silk, bottom, then the bottom silk. And man, I can't count and do that at the same time. Huh, I didn't know about that. Yeah. So anyway, so I could put that label down there on the different bitmap layers. And 209 would be on all of them, but then that layer would change. And it would just basically be the title block for that, saying what Gerber file it was. Oh, I could take 209 and I could make a whole little title block around it. Like, this is almost a little too much. Maybe like a none border would be better. But yeah, I can put it like a little. Here, let me show you a different one. Library open. miniPCB engineering DWG. Save, yeah, sure. So when I created the design standard, I created an Eagle library that I used to generate drawings. And just for fun, I played around with like different type of frames and title blocks. So this one's a vertical. That one's okay. The one I really liked was a different vertical. Part spec, that was one. Experimental, yes, that may be the latest. I thought it was schematic A vertical. Oh, was that what I was in? Okay. That's not vertical. Yeah. Not this one. So it was similar to the parts. It had to be the experimental. So part specification, yay. There you go. Like this guy, right? So you could imagine, take this, the top of this frame, drag it down, so it's kind of long like that, and then just this short little title block down here. Or no, just drag it down so that it's kind of, you know, whatever, and then just have a picture of the Gerbers. And then down here, it would be the Gerber file name. Yes. Oh, yes. Yes, 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 yes. So basically, you create an engineering drawing of the Gerber file name. Wow. Yeah. And then when somebody opens it in a Gerber file viewer, it should match. Yeah. and if I did that, I put those in the miniPCB datasheet after the schematic, put the Gerber files. Yeah. Gerber file images. And Gerber file drawings. Engineering drawings, Gerber, or just do I say Gerber files, like that. And then, you know, you're going to have your top copper, bottom copper, one per. I think so. Well, hang on. The Gerber files are actually going to be so that would be actually that. Okay, I like the idea of generating them. That is going to have to go in a script that's run on the panel. Yes. 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 Okay, so we're going to do that. We're going to have a a frame like this, but on the bitmap. Can I copy group? Cool, got it. Let me go to schematic. This is the experimental. A vertical none. Yep, paste. And I've been thinking about it, and I'm just gonna remove these guys. Not neat. Well, I had them there so that when people go to print this, the arrows will, be accounted for. So hopefully the border itself doesn't get cut off. But no, I'm just gonna have the border none. Not responding. No. Okay. Yeah, the old version of Eagle is fairly stable. There are only two things that are worth noting is I run it as an admin, so you have to right-click, say Run as Administrator. Otherwise, it won't commit saves to the libraries. You won't be able to make changes in the library. Okay. Copy. No. We'll just go back to experimental, and we'll start the experiment. So close. I want to. Okay. Whoa. Come back here. All right. And then the Eagle doesn't do just sheet one. Move. Properties. Just always going to be 1 of 1. 1 of 1. It's a big empty space, isn't it? You know what? This title block is not going to be as fancy as it first appeared. Okay, is A big enough? Let's do this. Let's say delete. Let's delete this bottom piece. Let's say move. Right click, properties. This guy, we'll just take it to 0. Grab this guy, move it down 1 click. Copy it. Then come up here, right click, properties. I want to be able to put 2 of these on a page, and it's approximately the width of a page. You'll have a little bit of that printer leeway because I made the frame smaller, and then it's got to fit like that. So I probably have 7 inches vertically to play with because of my header and footer. So 3 inches. But I want to do that in millimeters. So cancel. And let me millimeters. And 300. What, Nolan? Did I say 300? Right click here. Okay, so it's 250 tall. Let's make it why does that look wrong? Okay, that will be square. That's probably good right there. Let me see what layers are stuff here. Okay, so we got the symbols layer is 94. That's what I got everything on. So I'm going to just 94. Close that. File, script. What? Yes. Okay. Okay. Cancel. I didn't want to run it. I wanted to open it. Copy. File. New. No. Do have to do it this way. Okay. Let's see. Okay, I can't edit on the script from there. So I just have to come here and say open project. Yes. New script. Paste. That was a little painful, wasn't it? That's because I'm not good at it. We don't need to load a DRC. This is going to be run from the schematic. Well, for right now, yeah, we'll just no, what layers are? No, let's just do this real fast. Did I have it open? No. Okay. What can I copy and paste between the layers? Between like a board and a. Is it the document layer that copies between the two? So copy. Right click, copy group. Layer. Info. Guide. Well, V-score is definitely there. Modules. the bitmaps are there. Layer, bitmap. Right click, change group. Right click, change group. I have to select. Oh no, it changed that one. Yeah. There we go. There we go. Cancel. Copy. Selection. Put it on the origin. Copy group. Now we jump over to the board. Well, let's new. This is going to be miniPCB. No, it's image Gerber frame. Yes. Paste. Okay. Now, when I run that script, this when I run this, okay. This is not running the schematic. Run from panel board. Yeah. Okay. Set palette. What? Oof. Okay. I do want to do that DRC load thing, and I don't have a great memory, so I'm just gonna. I have two open at the same time, right? Okay, that stays, but I'm going to change it from 209 to 210. So 210 is going to have the Gerber. Ooh. No, we're just going to leave it 210. Yeah, it'll just all be viewed from the side Eagle's familiar with. Yeah, the holes will help them figure it. They'll be able to figure it out. Export image. Dun, dun, dun. Yeah. Okay, this should work. This should be good. Didn't I just modify this? Okay. Close that guy. Scaring myself. Yes, thank you. Export Gerber images. Yes. Okay. Yeah. Close that. Jump back over to here. Sorry, layer 210. Okay. Select all. change group, save. Copy group, because this is the drawings library. We're going to go to the real library. Control panel. miniPCB. Say miniPCB panel. Ooh, that's too fine. No. The revision is in the part number, the DWG number. It's I'm just going to put, for example, what was it, top? What was the Gerber file extension for top copper? GTC, Gerber top copper. Right click, left, center left, size. We're going to go up to 3.8 millimeters. Oof. That's 5 millimeters. It is going to be a 100 millimeter panel, so maybe it needs to be 5 millimeters. Yeah. I can put the, it's the DWG number, right? I don't think Eagle works that way. I don't think you can concatenate text, so it's just going to have to be I should just have that, instead of that rev, I should just have a line that says file extension, DWG number, and then file extension. Yeah. Yeah. Okay. Let's do it like this, though. Copy group. We'll grab the name with it. We'll grab all. I don't want all that. I just want that. Mm-hmm. That looks good. Okay. I don't need a symbol. Do I need it to be in a device to place that, or can I just place a? So if I go to the control panel and I go down to, since we did it together, I'll do it on this one. So here. So did I said save, right? Yeah, I saved it. So if I say library update all, and then I say place miniPCB, is it only showing me components? Because it was miniPCB panel. So I need to create a component. Cancel. Go back to here. Go up to component. Come over here. Say miniPCB underscore panel image Gerber name it train, yeah. New miniPCB panel. What? Yeah, there. Save. Jump back to here. Come down to here. Go down to miniPCB panel. Mm-hmm. Yeah, I'm rusty on it. It's been a while. Been doing most of my work in Altium. Library. Let me try to make sure I update all before. And then let me just go and add a symbol. Do I have a mechanical part? Let me do a pin. PCB info. That works. Okay, now we have a symbol. Now does it show up? There it is. Not sure if it was there already, guys. Sorry about that. Wow, that may be too big. That may be too big. Okay, let's go back to library. Let's edit package. What? Millimeters. Edit frame. Properties. 150, 120 by 150. That was the wrong. We can put it 150 by 150 though. Yeah, that'll probably be better. And then we'll put this on the 1 millimeter grid, and we'll group these guys. Move group. Oh no, it doesn't fit. I thought it'd be tight. Yeah. We can take off that asterisk. I'm gonna take off the dot because if I'm putting it in its own little cell, it doesn't need the dot. It's just ext file extension DWG nomenclature. Do they ever have 4? I don't think they ever have 4, but just in case, smooth it out a little bit. That's exactly the same, isn't it? Okay. Save. Jump back to here. Library. Update all. Okay. Move. Turn it on and say 5 millimeters. Grab this. Smack it down to a like that. Save. This is located at -25, -30. So if I could write a script to place this part, then I can add that to my panelize script. My panelize, yeah, it's that. It's the yeah. Cancel. Save. Okay, so if I'm here and I say script, export Gerber images, bam, it just did something, right? So now we go over to the folder and we will find date modified, date modified. Didn't put it in there, did it? Is it because I changed the project up to miniPCBs instead of this? Yeah, that's. Yeah. Okay. Let me go into this panel. Okay. Now we'll run the script. Yes. Wait, overwrite. Yeah, okay, well. Oh, man. Okay, so that's what the frame looks like. File extension DWG number. So, yeah. I want to you have to thread that needle. This is just for 2 layers. So Gerber layer top X, that's what I've been doing. I need to put this in my standard. Ah, oh, geez, that's not the standard though. This is more my like design notes, which is a very ugly document, guys. So, design files. I need just a part drawings, data sheet, protocol, layout. Gerber files. Insert table. Let's see, top. Rah, 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 rah. Top copper. GT. Gerber layer top copper. Gerber layer top X. Top cream. It's top cream. Yeah, it's here we'll do it like this. What's Nolan doing? He's not getting anything done. I know. It's all going to piece together in about 5 years. It'll be like awesome. Projects expand to fill the time allotted. I have to fill the next 80 years, guys. I'm not trying to get anything accomplished. I mean, if I accomplished it, then it would be accomplished. It'd be done. It'd be finished. It'd be kaput. It'd be, where's what do I do after that? Okay. So then I need to pick which layers. Layers in file, layers in image. What? Okay. So now I have a place to put that information. So So 1, 17, 18. $31, $32, 16, 16, 17, 18. Oh, by the way, this is how you know Eagle can do up to 16 layers, because the first 16 layers are reserved. The first, the numbers 1 to 16 are reserved for, well, your layers. Silk. T-place and 125. So that's 21. $29, $30, $20. That one may be, well, it's the dimension layer, so it's okay. I'll get over it. 102. Milling, 46. Okay, so those are the layers in the Gerber files. And now I basically want to take each of these and add, it was 210, and then a file, one that has the name of the file. Okay, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Save. Okay. File name, layers in Gerber, layers image. And it's all of these plus. I could just type 31, comma. Sixteen, 17, 18, 21, 125, whee, 22, 126, 29. What? I'm trying. What? Yeah, okay. 102 and 46. Save. Layers in image, layers in Gerber. Yeah. Now that I've got this specified in a design notes document, so it's not specified. Let's go to the control panel. It's export Gerber images. I do not want this to be called components top. That threw that off. So this is going to be Gerber top copper, like that. Yep. Yep. Okay, now we're going to just same song, second verse this. Copy. Delete. Okay. Well, slow down, Owen. You're too excited. Underscore. Backspace. Yes. Paste. Now, Yeah, what are you doing, Nolan? Get over here. Did I just... No, we are on. Okay. Oh my goodness. My brain lapsed. Y'all are like, no, we know. We're monitoring your every keystroke with a supercomputer to characterize your brain to find out what's wrong to try and save you. All right, you guys. Sounds awful expensive, though. Who's paying for all this? I am. Future Nolan is. Did he sign off on that? God damn, he can't stay in his own timeline. All right, we're almost there. Edge. Let's go grab those layers. V-score. Yeah, so my shop back here doesn't have any windows, and I made some LED lights that light it up very well, so it doesn't feel dark and dim. Feels very like you're in a lighted place, but you can't tell what time of day it is outside. So it's 11 o'clock at night, and it is just as comfortable as if it was 3 in the afternoon. Okay. Yes, this should do it. Okay, let's run this guy. This is what yeah. Yeah. Yeah, it's not going to have all the file extensions in, but it's something. We'll see what it looks like. Unknown layer 1. Really? Unknown layer 31. Oh, this is not good. Cancel. Why? There's layer 1. What do you mean unknown layer 1? Number. No. There's still layers over in the board, right? Well, yeah, that's where I've used the other one. What do you mean you can't display layer 1? Did I mess up my, so if I look at the export part image, no, it's just the display and then numbers. It doesn't have the commas. That was the problem. That, and that. That. Come on, Nolan. That. 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 Okay, I'll be quiet. You got to get some studying in, or creative thinking, or something. You're working on something too, so. Because nobody just sits there and watches this. They're always studying something. They're always working on something, listening to something, studying on something. They're always something with something. Okay, now this is going to work. You know how I know it's going to work? It's because I just got a feeling it's going to work. What? Yes. 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 Okay, let's see what those images look like. Let's go to the data sheet where we will be inserting them. Insert images from this device. Top. I should number them. Yeah, I should number them. Gerber. Well, for the sake of the video, I can just do this. Insert. There you go. And this shows so this would be the bottom copper. I should really put the outline on all of them. I should put the V-score. I should put the board outline on all of them. The dimension. It is the dimension layer, right? So if I say none, and I say dimension apply. Yeah, it's the dimension layer. Yeah. Okay, all apply. Okay, save. Wait, what number was that? Nolan. 20. Okay. Cancel. It's like, are you paying attention? Are you there? Are you there? No, not here. No, go away. Copy. We can put that there, 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 20, there, and there. Save. Okay. Do 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 do. Yes. That's a lot of clicking. Worst part is, I can't tell y'all anything while it's clicking, because otherwise the microphone cuts out. Well, delete, 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 delete. Poof. Okay. Let's zoom in again. We'll say insert pictures from this device, and we will select them again. We will insert again. Are they all selected? Just the last one. And we're gonna resize the actual size. Maybe I'll just center align them and then call that a day. That one's 2, 2. Okay. Oh, okay, cool. It center aligns them all because there's not a space between them. So this is what they will all look like when I get content in the title block there. They'll all have the part number, which will match what's up here. And they will have the file extension for the Gerber file that looks like this. So this would be top silk. The only thing that's actually not in the file is the outline layer, which I don't know. I've never included the outline layer in the file, but I don't know if that would be like we do it. We've done it. We do it at work. That's the way a lot of people do it. But I've just always had my eagle out job not include it. I don't know. Tell me to take it out once. Is that why? T-stop. Yeah, it needs to be able to have 4 characters. Remember when I was like, does it need to have 4 characters? Yeah, it needs to have 4 characters. Okay. So you got Gerber files. And then design inputs. So Gerber files really need to have like top copper so that it's in the navigation pane. And then I need to come here, say enter. And from here, it's control enter and home and this is the datasheet template, so might as well, right? cream. Oof. What? Heading 2. What? Give me those. Give me. Okay, you have to put the enters back here. Bum, 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 bum. Here, enter, control enter. Heading 2, the next one. So I did top cream. And bottom cream, bottom copper. So enter, control enter, heading 2, paste. Enter, control enter, heading 2, copy paste. Enter, 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 control enter, heading 2, copy paste. Enter, control enter. Well, I could have put another enter there. Enter, enter, control enter, heading 2, copy paste. Enter, enter, control enter, heading 2, copy paste. Okay. Okay. In every single data sheet, it's a lot of work, but it's probably worth it. It's probably good value add because it shows people, like, you know how many years I was into electronics and learning stuff before I learned about Gerber files and Gerber file extensions, and somebody earned the Nobel Prize for Gerber file prize. Is it the Nobel Prize? Gerber files, just Gerber files. This Wikipedia will have it. Gerber format. It's made by so and so, and he got the prize for it or something or other. Extended Gerber, yada yada. Other formats. History. Where's the I passed it. History. Where's history? Section 4. It's made by Joseph Gerber, blah, blah, blah. He worked here. He did this. He did that in 19 such and such. Yeah, National Medal of Technology. So Gerber files, the text file that encodes this, like this is encoded in text, well, ASCII, was developed by this guy, who lived between these. Yeah, I'm just reading Wikipedia to you guys. But anyways, they gave him the National Medal of Honor, and you know, good, because he deserved it. So anyways, yeah, so I think putting them in each and every miniPCB datasheet between the schematic and the design inputs is probably a good idea, because it just shows it. I think it's very educational. I think it'd show people what's going on, and then they could look at it and go, "Oh, why'd he put the kink in the trace like that? Oh, wait, come on, yeah, come on, there we go. Like, why, Nolan? Why did you have to? No, I know it's awkward though. Put it in the middle. I just hit it on the end. Oh, put it on this one. Don't have it come in straight. You know, it'll be fine. It'll be fine. It'll be fine. All right. Back out. 11:20. I should start thinking about going to bed, huh? Let's see. Well, okay. So today, what I wanted to do today was to create the script to make those. We did it. We figured it out. We do the mirror thing, and then we also just made a script to generate these images that show what the Gerber file is. Engineering drawings. What else? I think that's enough for one night. I think that's pretty good progress. Just all about Joseph Gerber. He needs more attention. The other guy I wanted to show y'all was stuff about Harold Black. He discovered negative feedback, or he invented the negative feedback amplifier. If you don't want to say he discovered negative feedback, but right, let's see, it was back here when he first started talking. I do want to say this. I will say this again, but I wanted to show it. So he had the idea while on his way to work, and while looking at the Statue of Liberty, the idea for negative feedback, like he came up with it. And let me advance this. Okay. So I wanted to. I wasn't planning on showing you all this, but I wanted to earlier. And so it's the end of the video. If you're hanging out with me still, then hang tight. You might enjoy this. So what he's drawn here, it's really fuzzy, is E, so a voltage source, and then he's essentially got some resistors, like a resistor networks, and then he is noting Ohm's law across, like the resistance, and then the current through it, and then the voltage across it, right? So, so that's what is going on there, and then, yeah. So, and he goes on to basically say that what he's written down here is the abstract model, and it can apply to anything. Not, it doesn't even have to apply to electronics. Like it applies to. He saw a lot of parallels between a lot of other different stuff, and yeah. Well, eventually I'll talk more about that, but because and the bottom line is electricity is electrons in motion due to a difference in voltage. And thermodynamics is about energy in motion due to a difference in temperature. And, right, empathy is about emotion in transit due to a difference in emotion, I say. And communication, again, I say, is knowledge in transit due to a difference, due to change, which is a difference. Yeah. So basically, I can see what he's talking about when he perceived that, oh, negative feedback, it applies to a bunch of stuff. So anytime you have a flow across essentially a conduit, you will have a potential that corresponds to that flow with respect to the element, and usually like resistance and conduct. If it's a resistive and conductive relationship, you're going to have a linear relationship. So you'll have like an Ohm's law formula, or you'll have the heat equation formula, which is Q equals C times delta T, right? It's a flow, a potential, and a conductance or a resistance. So anyways, yeah, so definitely check that out. And of course, go check out stuff about like Hans Kanenzind. Yeah, so anyways, I'm going to sign off, finish my beer even though it got warm, and call it a night. All right, thanks guys, we'll see you later.